Number 23, we got a nice question here about hair loss. And Nathan's losing 10% of his hair each year. So at the very end of the year, boom, 10% just falls out on the floor. It's probably a very stressful time. Probably make more sense if we were talking about compounded continuously. But he's losing 10% of his hair each year. So what we're going to do is write an equation for that. The amount of hair that he has left on his head, we're going to call the amount that he started with basically his principal. It's like his allowance for hair. And then what does the growth rate or decay rate look like? Since we're losing something, so 1 is what we started with. That's the 250,000 hairs. The minus sign means we're taking something away. What are we taking away? 10%. So that's 0.1. And how often are we taking it away? Yearly. So we put a T up here, and the T stands for years. So let's simplify that a little bit. 250,000 times 0.9 to the T. Okay. Now, without a calculator, this one's going to be really tough. You're losing 10% each year. You could do it. You're just moving a decimal. So we're going to lose 25,000 hairs in the first year. Boom. A lot of hair gone. But if you were to put that in your calculator with the T as a 10, okay, so T, this is 10 years. Then at that point, we're going to have 87,170 hairs. Okay. 10 years from now. Now this question at the bottom, I don't want to gloss over it because it's a really good question about that has to do with the domain of this function, the concept of losing some amount exponentially. At this rate, when will he have absolutely no hair on his head? So what are you going to put in? You would put in a 0 for A, right? So let me throw a graph up here for you. So if we have some starting point, 250,000 hairs, and the decay function looks like this. So it comes down and it flattens out. Right, so if we were going to do this function, we'd have 0, 250,000, 0.9 to the T. Divide by 250,000, that doesn't change 0 at all. 0.9 to the T. Then you'd have log base 0.9 of 0 equals T. You plug that in your calculator and it'll give you an error message. Why? What does that have to, what is that? That has to do with our range and domain of this function. Okay, so there are certain things that I can't plug in or that I won't get out for y when I talk about this exponential decay function, this part up here. So if you graph that, it looks something like this over here. And what's happening is you're decreasing. You're always losing 10%, 10%, 10%, 10%. Okay, so what's 10% of 1 hair? 0.1 hair. So this spot right here is what we call a horizontal asymptote. I'll put that word up here. Okay. An asymptote is something that we approach but don't reach. So we're approaching 0, but we're not going to get there, theoretically, when you talk about exponential decay. We get down to the atom and we can't split it, and so that's as much as we can do. So we're approaching 0, but we're never getting there. So if you wanted to, you could plug in a 1 right here instead of this 0. You can say, well, I can't figure out when it would have 0 hairs, but I could figure out when it would have 1 hair. And if you do that, you would get 1 hair at 118 years from now. So in 118 years, you'll have 1 hair. You're like, wow, that's crazy, because in 10 years, he lost a whole lot of his hair in just 10 years. So it's going to take us another 108 years. The amount of time in between Cubs World Series to get all the way down to 1 hair? Yes, because if you look at the progression, if you get down to 16 hairs, it's going to take you a year. Well, we're only losing 10%, right? So So it'd take us a whole year to get to 14. And then we're going to lose 10% of that, which would get us to about, I'll call it 12. It's 12.6, but and then we're going to lose another 10%, and we'll get to 11. Okay, so the progression, you can see at first the very steep slope, and then towards the end, your change is much less drastic. Okay, so it's going to take us a really long time to get to 1 hair, and then we're probably going to lose that one too. We're going to just give it up. We're going to stop doing the whole comb over thing. But the point of this is that you have an asymptote. It's something you approach, but you don't get to because we're talking about exponential decay. Exponential functions have horizontal asymptotes, and then our logarithmic functions, we talked about how this thing cannot be 0. It has to be greater than 0 because your logarithmic function has a vertical asymptote. It's never going, its domain can never reach that 0 point. All right, hope that helps.